Hi everyone. So this is activity 1.2. This is the first actual required activity for the semester that you will have to hand in when you come in for the final exam. So you're going to watch the video along and do it along with me. You'll have to have the activity printed out before you start the video so you can do it along with me. Sometimes I'll skip around parts. Sometimes I'll cross off sections. So you are required to have filled in exactly what the video covers. Okay, so this is a continuation of 1.1, talking about functions, and in this activity we're kind of looking at different ways to represent a function, one using a table, one using an equation, and then also looking at domain and range. So we're starting with a situation where we're talking about needing to fill up your gas, and you get good mileage, but the gas prices are just skyrocketing, and you're trying to figure out a budget. So number one here, two input variables that determine the cost of a fill-up. Okay, when you go to the pump, there's two things that determine what you're going to pay. One is going to be the number of gallons that you pump, and then the second is going to be the cost per gallon. Okay, so if we had those two kind of varying inputs, we wouldn't be able to do a whole lot with this. So the next thing we're going to do is we're going to take one of those variations out of the situation, and we're going to say, let's keep one of those set. Let's assume that you are going to we know how many gallons you're going to buy. So then the only really varying thing now is the cost. Okay, so the gallons that we're going to pump is a constant. So we're going to complete the following table. So this is just saying, well, okay, you're going to buy 12.6 gallons. Let's say the cost per gallon is 3. So in that case, I would end up paying $37.80. If it was $3.50 per gallon, I would pay $44.10. If it were $4, I'd pay $50.40, $56.70, and $63. Okay, so is the cost of a fill-up a function of the price per gallon? So thinking about what you did last week, thinking about, is there one output for each input? So we would say yes. We would say for each input, there is exactly one output, which is the definition of a function. So yes, this would be a function right here. Okay, write a verbal statement that describes how we figured that out. All right, how did we figure out all that, the cost of the fill-up? All we did was we multiplied the cost per gallon by how much we bought, and that we were keeping constant of a 12.6. All right, so now we're going to move into looking at let's write this as an equation. Let's come up with an equation to figure out that cost. So we would say that the cost is 12.6 times the price per gallon. Okay, you could also, you're going to see later on, we're going to write it maybe something like this. F of P equals 12.6P. That's just using function notation like you used last week. Either one is fine. Okay, so now here's our symbolic rule, okay? So we looked at it as a table first, and now we look at it as an equation, just meaning as in symbols, a symbolic rule. Okay, so now let's say we pick a different value. Let's say using the given equation to determine the cost, if the cost per gallon is $3.60, so we're filling in a different cost per gallon, and our total cost then would be $45.36. Explain the steps. Well, I mean, this is a really basic functions. We really just multiply the 12.6 times 3.60. Not a very fancy equation here, very basic. Okay, so now you see, I didn't look ahead, I should have. You see that they're writing it the way I did up there in the function notation. Okay, so it's very important to be able to use function notation. It's used a lot, especially in this class. So using function notation, write the cost if the price is $3.85. So we want to write it so the correct way. So I'm going to say, well, what happens if I put in $3.85 for my price per gallon. So then it looks like this, 12.6 times 385. And we get, oh, this is not, I thought I was rounding for a second. That should be a regular equal sign. We're going to end up getting 48.51. So they want us to write it as an ordered pair. So this is important to get in the habit of knowing which one goes first. Now, the input I used, this was my input. This was my output. So when I think about it, my ordered pair should be input, output. So that's my ordered pair. If I were graphing it, that would be my X, that would be my Y. Okay. So now we're going to start looking at, okay, so this is the same kind of thing. Let's just do this one really quick. F of 495, same thing. It's going to be 495 times, okay, I changed the order, but that didn't matter in this case, right? Didn't matter which way I multiplied those, so my fill-up would be $62.37 if the gas price went to $4.95. Okay, so write a sentence describing it. So it just means it would cost, just what I really just said, $62.37 if the price per gallon, if the price was $4.95 per gallon. I need a lot more space to be able to write neatly. Sorry about that, guys. So the next part here, I'm just going to kind of, I'm going to have you read through that. There's nothing to actually complete. It's just a kind of a quick review of real numbers and breaking them into rational versus irrational. Okay, so they're giving you lots of examples of what it means to be rational and then examples of what it means to be irrational. So those irrational ones are ones that could never be written as a fraction. So there are radicals that can't be simplified. Pi is a really good example. They're doing that just because you're going to see those terms when we talk about domain and range. So domain and range is something if you, I'll keep drawing lines on the side there, sorry. Domain and range is something that you should have talked quite a bit about in Math 095. So when you think about, there's a definition down here, but I just want to do a little quick. Every time I hear the word domain, I'm thinking all my X's, and when I hear range, I'm thinking all my Y's. Okay, so when somebody asks us what's the domain of a function, we're looking at what kinds of X's can I plug into this, and same thing for range. What kind of Y's can I get out of this? So you're going to see we're going to start talking about practical domain and an actual domain. We'll look at the difference. So now we're looking at a situation where we're training to run a marathon. The marathon's 26 miles, and we're assuming that our speed is going to be 6.5 miles per gallon. So we have a function right here to figure out how long we have left, the distance we have left for any hours we've been running. So if I wanted to know how long I had left after 1 hour, I'd plug into equals 1, after 2 hours to equals 2, okay, and so on. So can any number be substituted for the input? Okay, so theoretically, I could plug in if I didn't have any context to that situation and just saw that equation, I could plug in anything I want for t. But since I know that the 26 is a distance, if I start plugging in things too small, then I get negative distance. If I start plugging in things too big, the same kind of thing. Okay, so this is only going to work if I plug in, we can only use, we can't use negative t's, that wouldn't make sense, we wouldn't have a negative time. So we can only use times between, we'd have to start at 0. And I think if you plug in anything above 4, you would get stuck here because then my distance would start to go negative. So 0 and 4, anything between 0 and 4, any rational number between 0 and 4 would be okay here. Anything outside of there doesn't make sense. So that's what we start when we talk about practical domain. It's the ones that make sense for that scenario. Okay, so the actual domain can be different. Okay, so let's take a look.